Electron affinity means love for electrons, acceptance. Different elements have different tendencies for electron acceptance. When a new electron is entered to an atom, its nucleus attracts it, and thus energy is released out. Therefore, electron affinity is measured in terms of energy evolved. Thus, it is defined as the amount of energy released when an electron enters to the valence shell of gaseous atom to form an anion is called electron affinity. Whenever electron is added to valence orbital, the atom will always become anion, and negative signs appear on this atom. Whenever electrons added, a nucleus exerts some force of attraction on that electron. So amount of energy is released during this process. The energy which release is given negative sign when first electron is added to an atom because the energy is released. However, when a second electron is added to a uninegative ion, energy is absorbed and it is given positive sign. For example, in chlorine, when one electron is added, chlorine outer electronic configuration is 2, 8 and 7. 2 electrons in S, 8 electrons in Sp, and last orbital have 7 electrons. When one electron is added, its electronic configuration is 1s2, and second shell may 8 electrons and third shell may be 8 electrons. So electron affinity of chlorine while adding one electron is minus 348.8 kilojoule per mole. So it means that energy is released when one electron is added. Similarly, in another atom, oxygen, when one electron is added, oxygen become anion, minus 1 sign appears on it. As electron is added, first oxygen has electronic configuration 1s2, 2s2, p4. Now as one electron is added, its electronic configuration change. One electron is added, so its electronic configuration is 2 and 2s2, p3. So that's electronic affinity is minus 141 kilojoule per mole. But as I said earlier, that when a second electron is added to uninegative ions, similarly like oxygen minus 1 is a uninegative ion already. Another electron is added to same oxygen anion. So this time the energy release will be plus 844 kilojoule per mole. When a second electron is added, then energy is absorbed. First electron, whenever added, energy is released, and when second electron is added, energy is absorbed. Electron affinity is usually measured in joule per mole or kilojoule per mole. There are some factors that affecting the electron affinity, like atomic size. Greater the atomic size, lesser will be the electron affinity, because when size of an atom is greater, nucleus is far away from outer electron which is going to be added or which want to add, and nucleus will fail to exert its force of attraction to that far electron. That's why when atomic size is increased, electron affinity for electrons decreases. Second factor is the nuclear charge. Greater the nuclear charge, greater will be the electron affinity, because as protons are added in nucleus, so to balance or to make stable that element, जितने number of protons हैं उतने ही number of electrons में होने चाहिए. So for the same number of protons, electron affinity will increases to add more electrons to balance the number of protons inside the nucleus. Now the fourth factor which affects electron affinity is electronic configuration. Those elements which have a half-filled orbitals have low values of electron affinities. For example, group 5a, while elements with the completely filled orbitals and shells have generally positive values of electron affinity, like group 2a and 8a. Let's do some electronic configuration, then I will explain it more precisely. That 5a elements have half-filled orbitals, like nitrogen, which have atomic number 7. When we do this electronic configuration, so we found that it have a half-filled orbital. While that of group 2a and 8a elements, like group 2a may we will take a element like beryllium. Beryllium electronic configuration, when we do, it's have 2 electrons in s orbital, so it means it is completely filled. And group 8 we also know as noble gases. They almost have 8 electrons in their outermost shell, so they're completely filled. So the elements which have half-filled orbital have low values of electron affinity, and with the completely filled orbitals and shell have generally positive values.